Now let us understand work done against gravity. We have seen work done in a moving body till now, that is on a horizontal surface. When something is pulled or pushed on the ground, we need to understand when an object is lifted up. So it is moving in a vertical direction. When an object is lifted up, what happens when we lift an object? Work is done. How the work is done? By the force exerted by us on the object. Now, what happens to the object? The object moves upwards. The force is in the same direction that we exerted, is in the same direction as the displacement of the object. That we know. We are lifting it up and the force also in the same upward direction. So both are in the same direction. The displacement of the object as well as the force acting on the object as per the definition. However, you also understand when you are lifting the object, there is a force of gravity acting on the object. So in this case, we encounter a new force of gravity. This happens when lifting the objects. So when we take lifting of an object as an example, then there is a force applied on the object by lifting it up, but there is also a force of gravity by the earth, because force of gravity of earth pulls down everything towards the surface of the earth. So when we lift a book from a table, let us say there is a table, there is a book, and we are lifting the book. When it is lifted vertically upwards, what happens? We are doing the work against the force of gravity because the earth is trying to pull the book down. This is force of gravity. Gravity acting on the book, trying to pull it down, attract it towards the earth. Whereas we are lifting the book with some force. So what happens now? There are two forces acting on it. So when there is a work done because we lifted the book and the book has moved from its position to another position. So there was a work done because there is a force acting on it and there is a displacement of the book. So both the conditions of the work is satisfied. Hence we say work is done on the book by this force. But work is done in this case against the gravity, force of gravity. Against the force of gravity, this work is done when we are trying to do something in a vertical direction, unlike what we have defined earlier. So, we say whenever work is done against gravity, the amount of work done is equal to the product of weight of the body and the vertical distance through which the body is lifted. So, we say that in this case, when the book is lifted, the force becomes the weight of the body. Whenever work is done against the gravity, F becomes W. What is the weight? Weight of the body is mass into acceleration due to gravity. Which is nothing but mass if we say as m and acceleration due to gravity as g and weight as w, then w is m into g. Now what is the work done? We can take work done in lifting a body can be defined as this is also w. So not to have confusion between weight and work term w, we'll just write this as weight only. So Work done in lifting a body, W, is force, that is weight here in this case, into the vertical distance through which. So, which is height. Height is h. M into G into h. So, the book has gone through a height of h. So, we can take one more example in which we can represent the same thing. A staircase where a man is climbing up, and this staircase is of height h, and he is climbing up. So when he is climbing up, weight is his mass into acceleration due to gravity, and he has climbed up a height of h. For him to climb up all the stairs and reach here, the work done by him, when he reaches here, work done is mgh. So work done by the man in climbing up or work done in lifting a body, everything is the same. So in this case, work done by the man in climbing up a stairs of height h is mgh. So we conclude that work done against gravity is given as mgh, where m is the mass of the body, g is the acceleration due to gravity, and h is the height at which the body is lifted. Against gravity is mgh. The thing which we need to note down is, when a body is lifted vertically upwards, then the force required to lift it is equal to its weight. That's why instead of the force we use the weight.